Welcome to today's Explainer. Look, we're diving straight into something that is literally shifting how we interact with artificial intelligence. We're talking about a groundbreaking methodology in natural language processing called Directional Stimulus Prompting, or DSP for short. If you've ever felt like you're wrestling with an AI just to get it to follow your exact instructions, well, you're absolutely in the right place. We're going to explore exactly how we can finally tame the AI black box and truly steer these large language models exactly where we want them to go.
It's a totally frustrating reality, isn't it? I mean, we've got access to these incredibly powerful, massive AI models that can write beautiful poetry or code complex software, but then they completely stumble when we ask them to follow strict, instance-specific guidelines. You give them a clear rule, and sometimes they just flat out ignore it. So why is that? Well, to understand the solution, we first really need to understand the problem. Okay, let's dive into our roadmap for today. We're covering the black box problem, what DSP is, how DSP actually works under the hood, weighing the pros and cons, and finally, seeing DSP in action. Section 1, the black box problem. You see, when we use massive LLMs like GPT-4 or Palm, they operate as what we call black box models. And what that really means is we completely lack access to their internal workings. We can't see their parameters, their tuning methods, or how they actually make decisions. We're interacting with these powerhouses totally blind, relying entirely on text prompts sent via API calls. Basically, we put text in, and we just cross our fingers and hope the right text comes out.
And here's the bitter pill to swallow. While techniques like zero-shot or few-shot prompting have brought us some pretty amazing results, they frequently fall short. When a task requires guaranteed, systematic compliance, like adhering to a strict stylistic guideline, or including very specific key details, or following a tight reasoning pattern, conventional prompt engineering just struggles. It's simply not enough to guarantee consistent compliance for highly nuanced tasks.
Moving on to Section 2, what is DSP?
So Directional Stimulus Prompting, or DSP, is this brilliant methodology that introduces a small auxiliary policy model to generate instance-specific prompts. And these prompts actively guide the LLM. I actually love to think of this as a David and Goliath analogy. Picture this. You have this tiny, highly specialized policy model, that's our David, acting as an auxiliary steering wheel. And it's being used to completely control the massive LLM, our Goliath, pointing it exactly toward the desired behavior.
And this beautifully illustrates the difference. In standard prompting, you're entirely reliant on the basic quality of your initial text input. It's passive, right? You throw your prompt in and just hope for the best. But directional stimulus prompting distinguishes itself by establishing direct control. It uses a guiding stimulus as an active control mechanism for the model's generative process, practically guaranteeing that the model aligns with defined criteria. It is proactive steering rather than just passive hoping.
Section 3. How DSP actually works.
Okay, so DSP operates through two fairly heavy technical steps, but we can break them down really simply. Step 1 is supervised fine-tuning, or SFT, which you can just think of as teaching the rules. And step 2 is reinforcement learning, or RL, which we can frame as rewarding good behavior.
Let's look at step 1. Supervised fine-tuning is incredibly efficient because, well, we aren't actually trying to train the massive LLM itself. Instead, we take a much smaller pre-trained model, something like T5 or GPT-2, and we fine-tune it on a small, labeled dataset. Its one and only job is to learn how to generate what's called a pseudo-stimulus. And by training this smaller model instead of the massive LLM, you completely avoid those astronomical computational costs. It's a huge win.
So what exactly is a pseudo-stimulus? Simply put, it's the guiding signal. For instance, if you're tackling a summarization task, the pseudo-stimulus might be a very specific set of keywords or phrases drawn from a reference summary. Or, if you're doing dialogue generation, the pseudo-stimulus might be dialogue acts. That means telling the model the next output absolutely must be a request or a specific type of question. It's that direct, undeniable nudge the LLM needs to stay on track.
And then we hit step 2, reinforcement learning. After the small policy model learns to create these stimuli, RL steps in and allows it to explore and refine its abilities. It uses a reward function based on established quality metrics, like Rouge or Blue scores. Now, these scores essentially measure the quality of a generated text against a perfect reference text. This ensures that the policy model gets better and better at generating the precise stimuli needed to guarantee high-quality outputs from the main LLM. Let's move to Section 4, weighing pros and cons.
Now, looking objectively at this, the pros of DSP are highly significant. It gives you a targeted attention mechanism, meaning the model concentrates its processing power on the essential components. It massively optimizes resource usage because you need far less dataset training, which leads to way lower computational costs. Plus, it enhances precision by isolating the most relevant tokens. But on the flip side, DSP does have a heavy reliance on accurate cues. If your environment is noisy, its effectiveness definitely drops. There's also some configuration complexity here. Setting up those directional stimuli requires careful calibration. Finally, it has limited generalization, meaning it can struggle to adapt to unexpected input variations outside its core training. So yeah, it definitely demands a precise initial setup.
All right, Section 5 DSP in action. Let's look at some real-world wins.
Now, what's really interesting about this number here, 4,000, is its scale. In an experiment using the CNN/Daily Mail dataset for text summarization, DSP required a tiny, and I mean tiny, dataset of only 4,000 samples to learn how to effectively guide the LLM.
And with just those 4,000 samples, DSP generated a 4 to 13% improvement in benchmark performance. We're talking ROUG and Blue metrics, and even human preference scores. It actually surpassed some fully supervised models that were trained on vastly larger datasets. No way, right? But the numbers back it up. But wait, it gets even better. For task-oriented dialogue generation, basically teaching the AI how to hold a helpful, structured conversation, DSP was tested on the multi-WAS dataset. It needed an astonishingly low number of only 80 dialogues to learn the rules. Literally, just 80 dialogues. And those 80 dialogues, they led to a massive 41.4% performance boost. By plugging DSP into the process, it outpaced state-of-the-art giants like ChatGPT, Codex, and InstructGPT, which, as we know, were all trained on significantly larger datasets. It's an absolute testament to the power of precision over sheer volume. So the crucial point here is that DSP enhances chain-of-thought reasoning by generating instant-specific prompts that actually outperform human-designed prompts. Think about that for a second. It essentially beats us at our own game when it comes to guiding an AI through complex reasoning accuracy. It just knows exactly what buttons to push inside that black box to get the absolute best result. Which leaves us with this final thought. With directional stimulus prompting, we are no longer just talking to the AI, tossing text into the void and hoping for the best. We are actively steering it. It allows for direct control, optimal resource usage, and unparalleled precision. So I'll leave you with this question. As the AI landscape evolves from passive inputs to active control, are your prompts ready for an upgrade? Thanks so much for joining me for today's explainer.